Here we go. All right, so right here we're going to concentrate on the perfect square trinomial. I just got done making the video on difference of squares and addressed the problem of sum of squares in real numbers. This is kind of a follow-up video because it kind of breaks down into 5 different special factorings. There are ways to do it without memorization. If you can remember it though, oh, does it save you time. So if at all possible, it'll take you like 10 seconds to do these if you know the pattern. If you don't know the pattern, it could take you a while. It'll also take you, if you get really good at it, it'll only take you about 10 seconds to be able to determine whether or not you can. And if you can't, you've only wasted 10 seconds. But if you can, then you've saved yourself 3 to 4 minutes of hard labor. Or in the case where it's rough for you to factor these things, you could save 10, 15 minutes. I mean, I've had students tell me, yeah, oh, these things are terrible. And I show them this little trick. Okay, you just saved me like 4 hours worth of homework. All right, so here we go. Just as before, as in all of these videos that I make, I look for the order. I factor out the greatest common factor. Greatest common factor. And then I look for these special things. These perfect square with a Q trinomial. I need another one of these stylus pads, ones that are a little bit nicer, plus maybe my 2 monitors is causing the issue, I don't know. The difference of squares, which I just got done making. And let's just abbreviate here. And then the sum or difference of cubes. This is a different video, so we're not going to address that one here. But these are the 5 different things. Perfect square trinomial comes in 2 flavors. Difference of squares only happens in the difference, does not work in the sum. The sum of squares is not factorable in the real number system. The sum and difference of cubes are also split up into 2. So there are 5 different things that we can look for in step 3. And then finally, all else fails, just do the thing. Do the thing. All right, so let's get going. What I've done is I put a fairly generalized, it's not completely generalized, but it's a fairly generalized version of the perfect square trinomial and how it breaks down. If you don't believe me, take this right side here and square it out. You do not distribute the square. That's not what you do. The only time that works is when you're multiplying, not when you're adding or subtracting. So to do this for really, you have to rewrite this into ax plus b and ax plus b. And then if you're familiar with my other ones, you run the dirty 4-letter F word all over it. I hate the word FOIL. I really do. It demonstrates an incredible lack of how to do it. So I know I'm going to get a lot of flack from teachers out there. It's like, but that's awesome. Yeah, but it doesn't work for the others. It's distribution. That's all it is. The dirty 4-letter F word is nothing but a quick reminder of how to do it, not that it works every time. Okay, so let's get going. Again, generalized form. All right, so do we have, and this is where it's kind of fun to look at because we're going to really look at, do we have perfect squares in the front and the back? And we do. Are we adding? Are we adding the back? And we are. Okay, so on the surface, 2 of the 3 terms agree they're perfect squares. Good. That doesn't mean it works. The check comes here. So let me run you through one. Now, is it in order? Goes from square to 1 to none, so yeah, that works. Factor out the greatest common factor. 25 is made of only 5s, 49 is made of only 7s. They do not share common factors, so we're done. It is a perfect square trinomial, I will just tell you that right off the bat, but we're going to check it anyway. So here we go. if this thing works, then it must work this way. So what we're going to do is we're going to take the square root of the front term. That leading term, we take the root of it, we get 5x. So what did you square to get 25? 5. What did you square to get x squared? X. That's your first term. And then what we're going to do is we're going to find out what we squared to get to 49. And we squared a 7. Finally, this is something that you might not have seen before. But this little plus minus symbol right here, and this little plus minus symbol right here, you notice how they're in the same order? That means that if this one's plus, then so is that one. If this one's minus, then so is that one. This is plus, so is that one. And then we just close it off, and we square it. And we attempt to see, does it work? Well, let's check. It says take the value of a and the value of b and multiply it by 2. That should be what's in the middle term. So I take the value of a, which is 5, the value of b, which is 7. I multiply them together, I get 35. Then I multiply by 2. I get 70. Is that what this is? And the answer is yes. So the good news is we're done. This is the answer. It fits the pattern. So how quick can that go for really? Well, take the root of 25 is 5, take the root of x is x, take the root of 49 is 7, take down the middle sign, square it, 5, 7 is 35, times 2 is 70. It took what, 5 to 10 seconds? Once you get to this, it's not very long. If it doesn't work, like you had maybe 60 in the middle, okay, you just spent 10 seconds and it doesn't work. Now you have to do something different. That's step 4. Here, the next one is a slightly more complicated version, but only because it uses more of my 4 different rules. So step number 1 is in an order. I get my 2, then my 1, then my none on my exponents of x, and it is. Next piece, factor out the greatest common factor. Factor out greatest common factor. Alright, so 16, 48, and 36. Well, 16 does go into 48, but does not divide 36. So the next one would be 8. 8 divides 48, but 8 does not divide 36. Next one is 4. 4 divides 16, 48, and 36. So I'm going to pull out a 4. And what's left is 4x squared minus 12x plus 9. And then I take a look at my step 3, which is, hey, I have perfect squares on the ends, and I'm adding the last term. It's also decreasing by 1 each time, and so this fits the pattern, at least, on the surface of being a perfect square trinomial. What I need to do, though, is I need to check the central term to make sure it fits the pattern. So I'm going to go ahead and take the root of 4, which is going to give me 2x. I'm going to take 9, which is the root of that is 3, and then I'm going to suck down the middle term, and I'm going to square it. And then I'm going to check it. If it works, great. If it doesn't, tough. So 2 times 3 is going to give me 6, and I double that. Remember, if we go back up here really quick, we double that central term. So we multiply these two things together, we double it. That's going to give us a 12, which is exactly what we're looking for. So we just drop down the 4 and we're done. That is the answer. It worked. Again, there are other ways to do this. You can do them different ways and you'll be fine. For instance, if you don't remember this, then that's all right. We can do it this way. We're going to start here no matter what. 4x squared minus 12x plus 9. But then I can go back to a slightly different way, and that is, hey, I have a leading coefficient of not 1, which is unfortunate because if it was 1, it would have been a lot easier. But since it's not that bad. Now, this is a method that I use. It's not the method you have to use. I know of at least 5 different ways to do these things. So it's whatever fits you. But we just split up the front and the back into their different factor pairs. 4 can be split up into 1 and 4 or 2 and 2. 9 can be split up into 1 and 9 or 3 and 3. And then what we're going to do is we're going to take 1 from the front and we're going to take 1 from the back and multiply them. And then we're going to take the other one from the front and the other one from the back, and we're going to multiply them. And then we're going to add them according to that second sign. So when we do that, we end up with 2 times 3 is 6. 2 times 3 is 6. We add those two things together, we get 12, which is this number. These are your numbers. The 2's will go in front. The 3's will go in the back. Now, if they were different, you'd have to match them up. So this 2 right here, this first 2, and the first 3 match up. That means that they cannot go in the same factor. Ah! Sorry, I pressed the button that I shouldn't have. So they can't go in the same factor. So that 3 comes down to here. This 3 then comes down here. And the second sign says the signs are the same in the factors because you multiply them, you get a positive. And then the larger pairing of these two must be negatives, but since they both have to be the same, they're both negative. And you'll notice that fits, right after we bring down this 4, that fits our answer over here, 2x minus 3 quantity squared. Here, we end up just writing it out. No big deal. That's how you can kind of get around this. All right, one more. Oh, looks like we got 2 more because I have a fun one down here. Okay, here we go. Now we have x's and y's here. When we do this, we have to be very cautious to check that the central term agrees with everything else. You'll notice, however, that we have a setup that's very, very similar to this. We know that that breaks down into 2x minus 3 squared. So we're going to assume then that this is going to do the same, but we're going to check just to make sure. So we have a 2x, and back here we have a 3y. And then we take the middle sign down and we put that in parentheses and we square it. Now we have to check to make sure that we get the central term. Now, since this involves the y and we have a mixed set of variables here, I'm going to just quickly remind you that back up here, it says take what's in front, take what's in back, multiply them together, and that's what you get in the center. I was missing a y in that example, but here I do the exact same thing. I take this thing and I multiply it with this thing. That gives me 6xy, and I double it. That gives me 12xy. And so that's actually the answer. The end. Ta-da! See? Easy peasy lemon squeezy. If you don't happen to remember it, then you got to go through this rigmarole, and it might take a while. But you'll still get the right answer. Okay, last one. I promise. Shh, it's okay. Here we are. We have an x squared, and then we're adding in this junk. And so what we're going to do first is we're going to factor out that junk to see if we can do anything else. So number 1, is it in order? 2, then 1, then none. Yes. Number 2 is their greatest common factor just within here. And 9 is 3's. 12 is made of 3's and 2's. But 4 is made of only 2's, and so the 9 and the 4 don't agree. So there's no greatest common factor to pull out. And then if we look at it, it kind of looks like this last one here, except the 9 and the 4 exchange places, and that's exactly what they're going to do here too. So I'm going to attempt to check this to see if it's a perfect square trinomial. So 9 is a perfect square, 4 is a perfect square, and it's adding. So that's the other important thing. If this last term is subtracting, it's not a perfect square trinomial. It must add if it's a perfect square. All right, so I must have squared 3 and x to get that first term. I must have squared 2 to get that last term, and I bring down that middle sign. And then I put parentheses and I square it. And then I check. 3x times 2 is 6x, doubled, not squared, but doubled is 12x, which is exactly what's here. So that fits, good. So now I have this. Now I can look back and see, well, did it change anything? So I ask myself, very first question, is it in order? Yes. Is there a greatest common factor? No. These are the 2 terms. Those are the 2 terms. If there was a greatest common factor, this one would have had something out in front, as well as this guy here that shared a common factor other than 1. Since they don't, it has no common factor. From this point, then, we are dealing actually with the sum of squares. you'll notice that it's this piece squared. So it's x squared plus a bunch of junk squared. But that follows the x squared plus a squared kind of format. Unfortunately, without the use of complex numbers, we really can't do anything with this, so we just kind of let it be typically at this level. There may be a different way to factor it. We're not going to worry about it. So that's where that one breaks down, but that would be my answer. That's the answer. You can at least factor it to that point, so you should. If not, that's when teachers get angry. Like, you need to do it. All right. That's it. That's how the perfect square trinomials work. I deal with those at the exact same time that I deal with my sum and difference of cubes and my difference of squares. Those 5 things. So I have the 2 perfect square trinomials, plus or minus in the middle. I have the difference of squares, and I have the sum and difference of cubes. Those 5 things I'll check at the same time as step number 3 in my 4-step process to get through factoring. I hope this helped everybody.